Huh?
I hope you understand limiting velocity. And this velocity, so see here, upper pipe velocity is different and the lower bottom pipe velocity, which is near to the solid surface. That means pipe का solid से जो near contact में liquid है, their velocity is different. So because of this different velocity is called critical velocity. Understood, students?
Yes, sir.
Now we study more about critical velocity. Down. What is critical velocity? Certain limiting velocity of liquid below which the flow of liquid is streamlined. So again, we see the case in upper level. See, this is pipe, and this pipe the liquid is flow. Now each liquid flow we are divided into layer. This is upper layer. We know that the upper layer liquid velocity is very high because they are free move surface of liquid. But when we are going inside the depth of the liquid, which is contact to the solid part, their velocity is goes on decreasing because of interaction with each other. So if this difference of velocity, this difference velocity is called relative velocity, which is also called critical velocity. In water, this critical velocity is very less. Because of less critical velocity, the motion of the liquid in pipe is very fast. What about if we are putting honey or any viscous type of liquid in a pipe? What happens? Because of viscosity, the critical velocity of the fluid is increases. Because of increase in critical velocity, it turbulent flow is start. Turbulent flow means the liquid cannot flow properly. Understood? इसका flow बिगड़ जाएगा. Okay. You will see more details this turbulent flow and streamline flow. The opposite of streamline flow is called turbulent flow. Okay, so what is streamline flow? The velocity of liquid is less than critical velocity. Because of less critical velocity, जो water liquid होता है उसका जो flow होता है काफी fast होता है. That is why we are calling streamline flow. Now coming to turbulent flow. In turbulent flow, the critical velocity is very high. Because of high velocity, the liquid motion is random. जो liquid है वो proper motion नहीं कर पाता. Second point. First point I have clear. Second, flow is regular. In streamline flow, the liquid flow direction is same. All liquid flow direction is same. In turbulent flow, the direction of liquid is not same. They are in random motion or zigzag line. And the reason of behind this because of greater critical velocity. So this means each layer is not flowing proper. Each layer perform a force. We will see next concept is force of friction is part. Third point says all fluids move parallel to each other. Yes, this is true. First liquid and the second liquid. Each liquid parallel to each other, and this happening only in streamline flow. And here turbulent flow, there is no each liquid are not parallel to each other. They are crossing each other. Each liquid crossing each other. Fourth point says viscosity play a dominant role in streamline flow. In here, viscosity is less. In streamline flow, viscosity is very less. Turbulent flow, density play a important role. Here the density, viscosity is high and density if increases, it start turbulent flow. Okay. Generally occur in small diameter. Obviously, streamline flow higher big pipe में भी हो सकता है and small pipe में भी हो सकता है. That is why it occur in small diameter pipe में भी आ जाएगा. और but small pipe में the flow of streamline is low. Okay, student. किसका voice is coming? Next fifth point is says flow is steady. For example, एक river का जो flow है वो कैसा होता है? Their flow is continuously in the same direction and their motion is same. So that type of motion is called stationary or steady motion. For example, in your house, fan is moving. The fan motion is same continuously. So that type of motion is called steady motion or stationary motion. Okay. 6.6 flow is speedy. In here the flow is changing. Flow is not same. So that is why we call in turbulent flow the flow is speedy. Example, streamline flow example. One of the best example is the water flow in canals. या नदी का जो पानी होता है, one of the best example of streamline. Example in turbulent flow is hurricane, storm, flow of water in waterfall. These all example are turbulent flow. See, in starting waterfall की example है, तो starting में water एकदम flow रहता है, फिर जैसे ही waterfall आता है, वहाँ पे जो liquid water की speed है वो increase हो जाती है. This means that their velocities keep on changing. Understood? Now next
Yes, sir.
concept is viscous drag. Viscous drag is also called viscous force, and we एक और word है जिससे easily understand हो जाएगा viscous drag. That is the word friction force. So again we are coming to the same concept. Suppose we have a liquid, they are moving in one direction. Okay. Now the liquid is moving in one direction. This is the direction. And we know that in first layer, which is near to the atmosphere, the velocity is very high. But when we are going down, their velocity is keep on decreasing. And why they are decreasing? Because of pressure. Upper pressure is very low. Because of low pressure, the liquid flow is very high. But when we are going to inside the fluid, their speed is decreasing because of pressure is increases. Each molecule attraction is increases. Because of attraction, वो लेयर जल्दी से फ्लो नहीं हो पाती. अब ऐसे में क्या होगा? If the speed is different, each layer of fluid layer speed is different, it perform a friction force. अब ये फ्रिक्शन क्यों लग रहा है? बिकॉज लेयर का स्पीड डिफरेंट. मान लो ये लेयर स्पीड में और ये लेयर थोड़ी कम स्पीड में, तो ये दोनों एक दूसरे के बीच में एक फोर्स ऑफ फ्रिक्शन लगाएंगे. दिस अपोजिंग फोर्स इज कॉल्ड विस्कस ड्रैग और विस्कस फोर्स. आई होप यू अंडरस्टैंड. सो दिस फोर्स इज अपियर बिकॉज ऑफ रिलेटिव अपोजिट रिलेटिव मोशन. अंडरस्टूड स्टूडेंट? Now second top concept is velocity gradient. What is velocity gradient? Again we are taking the same example. Suppose we have a river. Now river water को की हाइट है, ये इसका रिवर बेड है. रिवर बेड वो प्लेस जहाँ पर सरफेस आ जाती है, जहाँ पे सॉलिड सरफेस आ जाती है लिक्विड की, यानी वाटर यहाँ से यहाँ तक है. ओके, दिस इज कॉल्ड रिवर बेड. नाउ वी नो दैट अपर लेयर का प्रेशर लो होता है. इफ देयर प्रेशर इज लो, द फ्लो इज परफॉर्म स्ट्रीमलाइन फ्लो होगा. बट व्हेन वी आर गोइंग द डाउन, द स्ट्रीमलाइन का जो फ्लो है उसकी वेलोसिटी कीप ऑन डिक्रीजिंग. तो स्टार्ट यहाँ पे थोड़ा डिक्रीज है, जैसे जैसे नीचे जाएंगे their layer base, their velocity is keep on decreasing, and that decreasivity will increases continuously when we are going depth to the liquid. When we are reaching to the river bed, in that place their pressure is very high and their velocity is very low. Now each layer velocity is different. See the example here. In river, the surface velocity suppose 5 meter. When we are going deeper, second layer, their velocity is 4. When we are going more in depth, their velocity becomes 3 meter, then 2 meter, then 1 meter. What this thing explains? The velocity is keep on decreasing when we are going inside the liquid. Understood, students? This decrease in velocity is called velocity gradient. So what is velocity of gradient? The change in velocity. Why the velocity is changed? When we are going inside the liquid, their velocity based on layer, their velocity is decreases. Understood? Based on height. So change in velocity upon height is called velocity of gradient. Now change in, because of change we are represented by dv, and height based on distance, this velocity of fluid flow velocity is changes. Understood? That is why it is called velocity gradient. Okay, understood, student, this part? Their unit is second inverse and dimension is L0, M0, T minus 1. Okay, everyone. Okay. Can you hear me, student? Great. मतलब एक साथ सभी म्यूट हो जाते हैं. मैं वापस से सिक्योरिटी हटा देता हूँ. Now, student, can you hear me?
Yes sir,
Understand this
अभी
part?
आ रही है
Yes,
आवाज.
sir.
म्यूट मत
And no
करो.
unnecessary voice, because this lecture is also watched by principal. Okay. Now, second concept is Newton's law of viscosity. See, everywhere Newton is there. So Newton also explained the viscosity concept by their own way. Newton says the viscous force. What is viscous force? Which that force which opposes the flow of liquid. Okay, is directly proportional to the dv upon dx. That dv upon dx is where we are getting this velocity gradient. And Newton says the viscous force is also depend upon the area of the fluid. कितने एरिया में फ्लूइड है और उस फ्लूइड पर कितना अपोजिंग फोर्स लग रहा है उसी लिक्विड की ईच लेयर के बेस पर. ओके, so viscous force is common, so we are combined both parts. What we are getting, force is equal to area into dv upon dx. Now we remove the proportionality sign by applying mathematical concept is equal to eta. Now here eta is constant and this constant is called coefficient of viscosity of liquid. We know that this part is nothing but the velocity gradient part. Now suppose in one condition where the fluid area is 1 and the velocity gradient is also 1. In that case, we are taking here 1. What we are seeing? The force, viscous force is equal to velocity, coefficient of viscosity. So this happens when this both parties equal, when this two values become 1. Okay. So unit of eta. So see, the force and eta is equal. So eta unit is same. What is the force unit? That is Newton second per meter square. Now here meter is also represented by decapoise. Now decapoise is nothing but meter square. Now CGS unit is dime second per centimeter square. Here poise means centimeter square. Now dimension is L minus 1 M1 T minus 1. We know how to find dimension. Now second concept is stopping. Suppose this is a river. Now river flow direction is right hand side, and I'm putting one sphere. Suppose sphere having some type of object. Now this sphere flow opposite direction of this streamline flow. This is called streamline flow. All liquid flow in one direction. Correct, na student? So this sphere flow opposite direction of this motion. So when they are flowing opposite direction, it will force. This fluid force is called friction force, and this friction force we call viscous force. Correct, students? So now based on this, what Stokes law says, if any sphere which is flow opposite direction of any fluid, it experience one force. That force is called viscous force. Understood, students? This is called Stokes law. So Stokes law says viscous force acting on a small sphere falling through a medium is directly proportional to radius of the sphere, its velocity through a fluid, and the coefficient of viscosity of the fluid. I hope you understand this part. Now how we are getting this equation, no need to worry, because in your textbook they are saying directly memorize this formula. No need to worry how we are getting this formula. Okay, students. Now viscous force. Now viscous force of fluid is depend upon. So viscous force fluid base पे किस पे depend रहता है? So they are saying shape and size of object. If the size of the object is very big, suppose this is a board, and this board is moving opposite direction of flow of river. So what happened? This board require machine, and this machine require more energy because they are opposing direction of this liquid flow. So this board experience a friction force or force. That force is called viscous force. Because वो force क्या करेगा liquid का, उसको oppose कर रहा है. वो oppose force, that is called viscous force. Understood, students? Now second, it depend upon the speed of the object. What is the speed of object? If the board speed is very high, so the viscous force is also very high. Third is viscosity of fluid. Suppose you are this sphere moving in sea or they are moving in river, because each समुद्र का जो पानी होता है खारा होता है, so their viscosity is very high. But when we are going to river, their viscosity is low because the river के पानी में salt is not present. If the salt is not present, their water is very light, their density is low. Correct, na student? Second, spherical object inside fluid. What is spherical object inside the fluid is depend upon. So it depend upon the radius of sphere. कोई स्फेयर कितना बड़ा है उस बेस पर स्फेयर पे विस्कस फोर्स लगेगा. सेकंड, स्पीड ऑफ द स्फेयर. सी द पॉइंट इज सेम. सेकंड एंड थर्ड इज कोएफिशिएंट ऑफ विस्कोसिटी. कितनी अमाउंट में उस पर अपोजिंग फोर्स लगेगी. Now we have the formula. I'm directly coming to formula because this part is not there in your textbook. So no need to worry how we are getting this formula. Directly memorize this formula. F is equal to 6 pi eta RV. This formula is proved by Stokes law. Okay. So there is no derivation in your textbook. So you directly come remember the statement and directly write this formula. Okay, students. Now next concept is terminal velocity. Terminal velocity is represented by Vt. Suppose एक person है, suppose this is a person and suddenly this person is fall in one wall or one river. Now common sense है, if the person falls from the river, they go to the inside the river. Right? Now, why they are going inside the river? Because of gravity. And gravity is increases based on mass into gravity. How gravity is work? Based on mass. If mass increases, their gravity is also increases. One more two force is applied on it. What is those two force? One is called upthrust force. This force is applying on this object, and second force is viscous force. Common sense, when they are person going inside the liquid or depth of the liquid, they feel the force, opposing force. That opposing force is nothing but the force of viscous force. Okay. Now, in certain case, they are reaching depth of the liquid. In this depth of the liquid, the gravitational force is become equal to the upthrust force and viscous force. ये वो level होगा जहाँ पर all force become same. Now in that condition, the person is going inside. Now they are not coming out. Okay, students. So in that condition, where each force become equal, that stage is called terminal velocity. I hope you understood this part.
Yes, sir.
Yes, students, Zoya.
Yes, sir.
Right. Okay.
Yes, sir.
So what is this terminal velocity? Where the weight is equal to upthrust force and viscous force. Now we represent the gravitation force by weight, and upthrust force we are using the symbol W, and viscous force we are represented by capital S. Now here upthrust force is also represented by pressure. Now we know the pressure exerted by any liquid is we getting the formula V rho G in starting derivation. Now the weight is fully depend upon gravity, mass into gravity. So we are representing the weight by m into g. Now here force, we know the Stokes law. Stokes law says what is the friction viscous force? 6 pi eta r Vt. We are just putting the value. We already know all these values. Okay. Now what we are doing here, except Vt, except this Vt, take whole side on left hand side. If we are taking whole side in left hand side, what we are getting? V rho G minus V rho G upon 6 pi eta. Now what is the common part in each part? V and G is the common part. So take Vg outside and the remaining part is inside. Now this V is nothing but the volume. And what is the volume? Here we are using the sphere. The sphere is falling inside the liquid. So sphere ka volume, what is the formula of volume of sphere? 4 upon 3 pi r cube. Remember? So we are replace this volume by 4 upon 3 pi r cube. Okay, students? And the remaining part is 3 as it is. Now we know that the 3 to the 6. Sorry, 2 to the 4, 2 3 the 6. So what we are getting? 3 into 3 is 9. So 2 upon 9 r square g. Now this pi and this pi is cancelled. So r square g sigma minus rho upon eta. This is the terminal velocity formula. With the help of this formula, we can easily calculate any types of body, the terminal velocity. Second concept is Reynolds number. So what is Reynolds number? It is a pure number which determines the nature of flow of liquid through a pipe. So simply, what is Reynolds number? Which calculates the flow, okay, of any liquid. Okay, students. So formula is already given. You no need to worry how we are getting this formula. The book directly give you this formula. So directly memorize this formula. Okay, students. So the formula is N is equal to Vc rho capital D upon eta. Here Vc is nothing but critical velocity, rho is density of liquid, and capital D is diameter of the tube, and eta is the coefficient of viscosity. Okay, students. Now, scientists say if the nature flow or Reynolds number is between 0 to 2000, so the flow of liquid is very smooth, it is streamline flow. If this number is increases, the streamline flow change into turbulent flow. If this number is greater than 3000, the flow is liquid is turbulent flow. Okay, so this number is increases, your flow is become your flow disturbed. If the number is less, your flow is low. Okay. Now, second concept is Bernoulli principle, and one good news is this part is removed by this timer. This 2020 portion, this part is reduced. So Bernoulli principle you have no need to study. Crossin law, no, ये भी study नहीं करना है. Venturi meter, नहीं study, no need to study this part. Equation of continuity, no, ये part भी study नहीं करना है. Bernoulli equation, no. This time this part is removed. 25% में ये सब remove हो गया आपका. So hydrodynamic part is done. Now we are coming to hydrostatic part. Remember, when we start chapter, we are doing two parts. Fluid part is done. Now this is the second part of this chapter, that is surface tension, hydrostatic part. Okay, so we start the second part. So first we understand second part. Surface tension I am representing here in this chapter by S dot T symbol. तो कहीं पर भी तुमको S dot T symbol दिखेगा तो understand this is surface tension. Okay. Now surface tension on the basis of molecular theory. What is molecular theory? We already know in chemistry. We already learned this molecular theory concept. In molecular theory, we first understand intermolecular force. So what is intermolecular force? See, we know that in any object, if we have two objects, suppose two atoms or pair, like sodium or chlorine, any type of atom, two atoms, either these two atoms attract each other or either these two atoms repel each other. This property is called intermolecular force property. But molecule word है ना, so suppose we have two molecules H2 and H2. Either these two molecules attract each other or either these two molecules repel each other. This type of property of liquid is called intermolecular force property. Now this property is more in solid state. The force of attraction in solid state is very more. Why? The bonding is very strong. But there decreases in liquid and very less in gas. Now this force is classified into two ways. One is called cohesive force and second is called adhesive force. This is done in your class 11. Remember students, I hope you study this part in chemistry. Now what is cohesive force? The cohesive force, suppose I have molecule HCl and second molecule is also HCl and both attracted each other. So this type of attraction is called cohesive force. So I hope you understand. Cohesive force, the force of attraction between two same molecules. Understood? This two molecules is same. So this type of attraction is called cohesive force attraction. This attraction is very weak. So weak attraction is represented by van der Waals force, or either this attraction is very strong. So इस केस में क्या होता है? Either attraction is low or either attraction is strong. Example: water molecule. The two water molecule attraction is called cohesive force. Force attraction between two bromine molecules. So both molecule is bromine, same type of molecule, but the attraction is called cohesive force. Okay. This type of attraction is also called intermolecular attraction. Now we see the adhesive force. What is adhesive force? So suppose I have one HCl. Suppose a container I having liquid. Now we know that liquid water formula is H2. Now I am putting salt. Salt formula is NaCl. What happened? This salt is dissociated in liquid and it becomes Na plus and Cl minus. Correct? Now this sodium and chlorine is attracted to water molecules. Understood? They are each making a bond. So here sodium chloride is another molecule and water is a different molecule. So these different molecules attract each other. This type of attraction force is called adhesive force. So different substance attract each other. This type of force is also called electrostatic force. Scientists say this as attraction happened in charged molecules. Suppose water molecule having charge, and this HCl molecule is also having charge. So charged molecule perform this type of adhesive force. Example, the attraction between water molecule and wall of the container. See, this is the wall, ग्लास वॉल. वाटर मॉलिक्यूल का कुछ ना कुछ अट्रैक्शन तो ग्लास से होगा, कांच के कंटेनर पे रहेगा. स्टिकिंग पेंट ऑन द वॉल, हम घर में जो पेंट मारते हैं वॉल में, दीज आर द गुड एग्जांपल एडहेसिव फोर्स. वॉल का जो मिक्सचर अलग होता है, पेंट में डाइज होता है. चॉक ऑन ब्लैक बोर्ड इज वन ऑफ द बेस्ट एग्जांपल. चॉक ब्लैक बोर्ड में कैसे स्टिक हो जाता है, दीज आर द एग्जांपल ऑफ एडहेसिव फोर्स. बोथ आर डिफरेंट थिंग. This type of force happen in intramolecular attraction. Intra means atom base. Suppose we have H and chlorine. Each atom base attraction is called intramolecular attraction. Understood? Intra.
Yes, sir.
Now we go further. Range of molecular attraction. Now here scientists say the maximum distance between two molecules. So suppose one molecule is NaCl and second molecule is HCl. I'm taking random two molecules. Now their range means their distance. One is here and one is here. Up to which the intermolecular force are effective. So मुझे इन दोनों molecule के that range we have to put that the force of attraction is effective. That means force of attraction is there. If you are making a large distance, force of attraction is not work. Force of attraction work only when the distance is at particular distance. What is that distance? So that distance is represented by scientists 10 raised to minus 9 meter. अगर दो मॉलिक्यूल के बीच में if you are putting this distance 10 raised to minus 9 meter distance, so what happened? Molecular attraction happen होगा. अगर इससे ज्यादा का distance हो गया तो molecular attraction happen नहीं होगा. Understood, student? This at range of attraction is called short range. Second concept, sphere of influence. Sphere of influence, an imaginary sphere. Now here the molecule is represented by a circular sphere. Okay. Now this imaginary sphere we draw with the given molecule, and now this part is their center, and from center to circumference distance is represent the radius, which is equal to the molecular range. Molecular range we already know, 10 raised to minus 9 meter, where the molecule attracts with other molecules. Okay, students. Next is free surface. What is free surface? So we see the example. We have glass. I'm putting water in that glass. So the free surface, this upper layer surface, which is free from air, this surface is called free surface. Okay, students. The topmost layer of the liquid is called the free surface. This layer is contact with air. Okay. Second is surface film. Suppose I'm taking a milk on a glass और मैंने उसको फैन के पास रख दिया था. You will see there is malai occur in their surface. जैसा मलाई आ जाता है.
Yes, sir.
So that malai is called surface film. Okay, students. The surface film is nothing but the thickness of the layer which is on the topmost of the liquid. Okay, students.
Atmospheric.
And why this malai is occur in milk? Because of attraction, molecular range of molecular attraction of each particle of the liquid. Now second is surface tension on the basis of molecular theory. This part I hope you done in class 11. We take a random 3 molecules. First molecule is deep inside the liquid.
Yes.
Okay. We are name it A. Second is half is deep in the liquid and half is open air. That is point B. And second C. C का तो 80% हिस्सा outside है and the 30% part is deep in the liquid. Now we know that in A part, the liquid, each liquid perform equal pressure or force in all directions. This part is already done in viscosity. Remember, मैंने बोला था हर एक लिक्विड पे जो दूसरा लिक्विड है वो इक्वल प्रेशर लगाता है ना. हियर द लिक्विड वो स्टेबल रहेगा, बट इन दिस केस, इन दिस स्टेज, half of the liquid is outside. So here जितना वो फ्लूइड के अंदर है उतने में इस पर इक्वल प्रेशर तो लग रहा है, अंडरस्टूड. बट द एयर प्रेशर पे कुछ प्रेशर लग रहा है क्या? नहीं. व्हाई? बिकॉज एयर प्रेशर इज वेरी लो. एयर का प्रेशर लिक्विड के प्रेशर से लेस होता है, अंडरस्टूड स्टूडेंट. बिकॉज ऑफ दिस प्रेशर इज कमिंग इनसाइड. प्रेशर क्या कर रहा है लिक्विड को? वो चाहता है कि दे आर कमिंग, दे आर पुलिंग इनसाइड, अंडरस्टूड. In C condition, the liquid pressure is very less and the air pressure is high. In this case, the pressure is below. We know that the air pressure is very low. So there, this liquid is pulling downward because of the pressure. Each pressure, यहाँ तो सब जगह से equal pressure था, but here the pressure is not same because of this pressure. All fluid pressure try to pull this liquid downward, but still ये लिक्विड डाउनवर्ड क्यों नहीं जाता है? बिकॉज देयर इज नो स्पेस. इस लिक्विड को डाउनवर्ड जाने के लिए स्पेस तो होना चाहिए. इनसाइड देयर इज नो स्पेस, ऑलरेडी बहुत सारे लिक्विड पार्टिकल हैं. एंड सेकंड इज ईच लिक्विड हैव सम एनर्जी. दिस एनर्जी इज कॉल्ड सरफेस एनर्जी. जो सरफेस पे लिक्विड होते हैं ना, उनके पास कुछ एनर्जी होती है. जैसे वी हैव एनर्जी, दैट इज कॉल्ड पोटेंशियल एनर्जी. सिमिलरली दिस लिक्विड हैविंग एनर्जी. Because of this energy, they are stable in the surface of the liquid. This energy is called surface energy. Understood this one? So we see
Yes, sir.
we done this part A, B, C. What is A, B, C? Molecule A attract in all directions. We see the attraction. So their net force is 0 because in each direction their force is same. But molecule B and C, their force of attraction is not same. And why their force is not same? Because half part is present in air and half part is present in the depth inside the liquid. Now, molecule B and C adhesive forces happen because they are having different types of forces applied on this. Air का force लग रहा है और liquid का, दोनों force different है. If the different force is attracted to the liquid sphere, that force is called adhesive force. Remember this part.
Yes, sir.
Now, similarly, because of this, B and C experience a net downward force. But because of surface energy, they are not going inside the liquid. Okay. Now, here the definition of surface tension. The property of liquid surface is called surface tension. The property of liquid surface means surface पे जो liquid stable रहते हैं, उस pressure को, उस property को surface tension बोलते हैं. And why these are stable in surface? Because of surface energy. So the extra energy that a liquid surface hold under isothermal condition, there are some extra energy which hold the liquid in the surface. That energy is called surface energy. See the definition is here. Isothermal means at constant temperature. SI unit is joule, CGS unit is arc, and the dimension is, we know how to calculate dimension, L2 M1 T minus. Now we are coming to the near to the surface tension concept. What is surface tension? So surface tension. Now this tension weight is approximately equal to the pressure work. किसी thread पे जो tension होता है वो pressure ही तो होता है, correct? So we know that the formula pressure is nothing but force upon area. Similarly, the word is tension. So the formula is force upon length. Why I am representing length? Because we know that tension सिर्फ कोई लेंथ पे ही अप्लाई होता है, ठीक है. लेंथ का एरिया नहीं होता, लेंथ होती है. दैट इज व्हाई वी आर रिप्लेसिंग एरिया बाय लेंथ. Suppose in one condition the length is 1. In that case, if we are putting length 1, in this condition tension and force become equal. Remember, pressure, force and tension ये सारे एक ही वर्ड की तरह काम करते हैं. इन दो सभी का मीनिंग सेम है. Now here I am representing tension by pressure. That is why we are taking a unit of pressure Newton per meter or joule per meter square. CGS unit is dyne per centimeter and dimension L0 M1 T minus 2. As you understand this part?
Yes, sir.
Okay, for Hindi lecture मैं हिंदी का भी वीडियो अपलोड करते रहता हूँ. So I am putting 2 uploaded video. One is English video, your lecture video, and second is Hindi video. तो किसी को अगर लेक्चर का और डिटेल जाना है तो वो यूट्यूब पे भी जा सकता है, ठीक है.
सर लिंक
Okay,
भेज
sir.
देना ना सर,
हाँ
लिंक
वो सब,
भेज देना इधर
हाँ मैं
WhatsApp
लिंक
पे।
में भेज दूंगा, पर्सनली भेजना पड़ेगा। मैं
हाँ,
जोया के पास है, जोया से ले लेना, ठीक है। वो
Yes.
सब तरह
जोया
फोटो ले
जोया
लिया
को
आपने?
भेजे हो?
जोया के पास
Yes, sir,
वो
जोया
ऑलरेडी
मुझे भी देना।
बहुत पहले ज्वाइन किया है मुझे
हाँ
चैनल को
ठीक
मेरे,
है।
और ऑलरेडी देखो